Want to welcome you and thank you for joining us for this 1 hour code breaker. As we get settled, a few reminders before we get started. Please use the Q&A section for questions today, and remember to be constructive in those comments to the presenters and to one another to ensure that we have a session that is productive. Also, AIA California will submit one AIA HSW learning unit for those who complete the session in full. And as always, the webinar content and additional resources will be available online shortly after the session. Today's webinar, which will focus on requirements in California's 2022 Energy Code for non-residential, hotel, motel, and multifamily envelope features, is brought to you by Energy Code ACE. It qualifies for one HSW learning unit, and we will submit those units for you after you finish in full. Now, quickly to introduce our presenter. Gina Rodda is currently the principal and owner of Gable Energy in Castro Valley and has been in the energy modeling field since 1991. Gina is the instructor of several dozen full-day Energy Code ACE trainings on the residential and non-residential Title 24, Part 6 Building Energy Efficiency Standards for building department staff, energy consultants, engineers, and architects. She is also a certified energy analyst, a lead accredited professional, and Title 24 energy analyst, performing a wide range of responsibilities in both residential and non-residential construction pertaining to compliance standards and energy modeling, and is a respected subject matter expert informing the statewide code development process. Gina, thank you so much for being here. Please take it away.
Okay, I am going to figure out, oh, yay, it's the right screen. Okay, that's just exciting right there, that it looks like we have the right screen going. Do you see my screen?
Looks beautiful.
Okay, now I got to tell you guys ahead of time, I have a lot of content for you today. And if you've seen any of my sessions in the past, you might be like, well, Gina, you always have a lot of content. Well, even more content. So I'm going to apologize now for how quickly I'm going to be speaking. There is a handout associated with this that will be provided to you. And I'm hoping, because we're trying to deal with non-residential buildings, hotel motel buildings, and some of the new pretty revolutionary requirements associated for multifamily buildings as we discuss just the envelope requirements of the Energy Code. So we already went over the course objectives were, so yay, I don't have to spend much time on these slides because you guys know what you're here for. I'm hoping all of you have taken the time to check out the Energy Code ACE website. We have tools, trainings, and resources. One of the tools I want to highlight for you guys today is our Q&A tool. This is a series of questions that have been asked by the industry and the answers that have been curated by the Energy Commission. And it's extremely robust. I think we have over 4,000 Q&As in this particular tool. And if you don't find the answer to your question, you can then submit a question, and we typically answer between 24 and 36 hours is our typical response time. If you guys have questions on the Energy Code and would like to have a subject matter expert answer those questions for you. We have training. I'm hoping you guys have experienced some of our more robust training beyond just these lunch and learns that we do that we call code breakers. We have some pretty exciting architect classes, one for single family and one for non-residential. And we're hoping to come out with our multifamily one later on this year. Resources. I'm super excited to tell you guys that we just came out a couple weeks ago with our fact sheet on non-residential envelope. And that is part of, we're going to touch on some of the information in that fact sheet with this presentation with you guys today. Remember, everything at our website is at no cost because it's already funded by you, the ratepayers of California. So come use your investment that you have already provided into by using some of these tools, resources, and training available on our website. Now, basics. I'm hoping all of you know we're in a 2022 building code cycle. And this goes into effect for projects that apply for permit as of January 1st of this year. If you applied for permit last year, you're subject to the 2019 Energy Code. If you applied for permit as of January, the 2022 Energy Code. It's not based on when you're approved. It's not based on when you start construction. It's all about that application date. Here at Energy Code ACE, we use these 3 symbols and color schemes throughout all of our resources and classes to help identify what is a mandatory requirement versus a prescriptive requirement or a prescriptive compliance approach versus the performance compliance approach that can be utilized to show compliance. Now, what are these mandatory measures? Mandatory measures are the first building block, and these are measures that were found to be cost effective for all scopes of work. And that's new construction, the least expensive time to integrate energy efficiency, additions and alterations. Alterations are the most expensive time to integrate energy efficiency measures. And every energy code requirement, with the exception of indoor air quality, has to show compliance to cost effectiveness evaluation, of which that particular building feature will pay for itself over its lifetime with energy savings for it to become an energy code requirement. Now, built on top of mandatory measures are our prescriptive measures, which is also a compliance approach. Now, prescriptive measures are based on climate zone. It's based on scope of work. We might not have the same prescriptive requirements for all building types, for all scopes of work, for all climate zones. We need to really understand what is your project, where is your project, and what is the scope of your project. You can use the performance approach to get flexibility of prescriptive measures only. Now, you can trade down to as bad as mandatory minimums, but you have to have equal energy savings that offsets that penalty to be able to have a compliance document that says building complies. Now, we're going to talk a little bit about what are the different ways we can show compliance for just the envelope. So I just want to talk about envelope right now. Now, we have a new series of forms in this code cycle. We have our non-residential forms that start with NR that apply for non-residential buildings and hotel motel buildings and high-rise multifamily buildings. Those are high-rise buildings that are 4 habitable stories or more. LM is the brand new series of forms that was introduced in this code cycle, which stands for low-rise multifamily. So the LM forms would only be used for a multifamily building that's 3 habitable stories or less. LM forms typically have to be registered with a HERS provider. Now, there are hiccups in that particular process right now, and the Energy Commission has put out a regulatory advisory indicating that right now we can't register these LM forms. And what they're saying is, and when we can register LM forms, the design team is to register them, even if you're in the middle of construction. And we go back and we make sure we have these registered documents so that the in-the-field documentation regarding testing and verification is linked up to the registered certificate of compliance form. So right now we have forms that have a watermark saying cannot be used for compliance. This is not registered. We would have to support, hey, I can use these because of this regulatory advisory. And that is how I go about submitting for compliance to the building department. Now we have a question, is the LM forms in AutoCAD? Now the LM forms have to be created from either state certified software because you're using the performance approach, or a compliance tool such as Energy Pro, which is a third-party software choice, or with the virtual compliance assistant, which is available for free on the Energy Code ACE website, or by using the paper static forms that have recently been provided by the Energy Commission that are not user-friendly whatsoever, and I strongly recommend no one goes there. Once we have the registration process in place, there will be an additional option for these LM forms in which you would get them via a HERS provider site. Currently, we have 2 providers, CalCerts and Cheers. So this is not something that's going to be the same for every single project. It evolves and it's based on your scope of work, it's based on your climate zone, and it's based on your design parameters. So we have 4 layers of forms. We have the certificate of compliance. This is the promise of how your design is meeting the energy code. Typically, you would engage an energy consultant, or you decide on your design team who's going to be responsible for this compliance documentation. But they should be working closely with you, the architect, to be able to determine if the design parameters that you have are meeting and or beating the energy code. One of the biggest mistakes I find happen is the mechanical engineer takes care of mechanical, the electrical engineer takes care of electrical, solar team takes care of PV and battery storage, but everyone forgot to think about who's documenting the envelope. I can't even tell you how many times in a year I get a job that went through plan check, and the plan check comment was, where is the envelope compliance documentation to the energy code? And it's the worst time to determine how your envelope is meeting the energy code once you fully designed it and you submitted it for plan check. So please really consider thinking about a process of how you're going to capture how compliance is going to be documented, coordinated, and achieved as a design team from the very beginning, so that we don't have to have those hiccups happen for your projects. The certificate of installation, acceptance, and verification are in the field forms that are provided and required to be provided by the installing contractor, a certified acceptance test technician, or a HERS rater if it is a verification procedure. Now, there are 2 methods that we can show compliance for the envelope. We can use state certified software via the performance approach. Currently, right now, there are 3 options for non-residential buildings. We have CBEC, which is the state provided software that is free. We have Energy Pro, which is a third party for sale product that also does prescriptive, also does single family, does a lot of things. It's a popular choice. There's also IESVE, which is really unique because it is a 3D modeling tool that can help support the performance approach. So there's choices, and we have to decide which pathway we're going at the beginning of a project. Or we can use the prescriptive approach, which is documented with the NRCC E&V form for a high-rise multifamily non-residential building or hotel motel building, but it would be an LMCC E&V form if it is a low-rise multifamily building. Now, there is a letter at the very end of all the compliance forms, and they help support who's responsible for enforcing the information within that document. E is the authority having jurisdiction, the enforcement agency, the building department. H would be the HERS rater, which is typically associated with the CV forms. Field technician, that installing contractor, or acceptance test technician, which is a certified acceptance test technician for our acceptance testing. Now, I think this is an important conversation for you guys to be aware of, because how are you making sure that the contracts and the requirements required of the contractors is fully being supported with your design documents, specifications, and work orders, so that everyone knows who's doing what, when they should be on site, and how to not be stuck at the end of the day not getting your occupancy permit because all of this process, testing and verification, has not been accomplished before you submit for final occupancy. Now, the virtual compliance, I can do this. The virtual compliance assistant is a free tool available through Energy Codeace that will help support the certificate of compliance documents. It also has a new process that's been introduced brand new for this code cycle for the certificate of installation forms for the contractor, in which it pre-populates what was promised with the certificate of compliance. Why is that important? Well, the certificate of compliance forms can get overwhelming. How many of you guys go, oh my gosh, my project has 10 pages of sheets just to support the certificate of compliance form for the energy code, and I can't even read most of these? Well, the contractor gets overwhelmed also. The certificate of installation will just show that contractor's scope of work. And I've been telling people, do this before you start engaging contractors. Do this to help support the bidding process. So like I, as an energy consultant, I am providing these installation forms that are bringing just that scope of work for whoever's doing the envelope, who's doing the windows, who's doing the mechanical systems. So they really know what they should be bidding on and what's expected of them. So it might be something you might want to consider as a design team to help support the contractor down the road. Let's stop talking about contractors now and let's start talking about design. Now, the importance of climate zone is incredibly invaluable when we talk about the envelope requirements, because remember, prescriptive requirements are based on climate zone and that cost effectiveness factor. So climate zone will dictate how much insulation is needed, how many layers of insulation are needed, so that you can meet the maximum U factor requirements of the energy code. And if you find you cannot meet these maximum U factor requirements of your climate zone for your building type, well, that's when you have to start considering, should we be using the performance approach to get flexibility because of the design parameters and the scope of work that our building owner would like this building to entail. There are some important definitions when we talk about the envelope, because the envelope requirements, with an exception associated with daylighting, in which we want to bring natural light into large volume of spaces, whether they're conditioned or unconditioned, everything else in the energy code applies to conditioned spaces only. And I find a lot of people don't understand what is a conditioned space. Well, we look at the conditioned space as the definition in the energy code. Now, the definition in the energy code of a directly conditioned space is a space that's being provided with wood heating or mechanical heating or cooling systems that exceed a 10 BTU per square foot of heating energy, or 5 BTU per square foot of cooling energy. So sometimes I'll have a large warehouse and they're like, Gina, it's a large warehouse and they're packing some boxes over here in the corner. So we're going to do a little bit of spot heating, or it might be mats, it might be a unit heater. Is this warehouse conditioned? And a lot of times I'll do the math and go, nope, you guys haven't exceeded the 10 BTU per square foot that defines this space as conditioned. So we do not have to meet the envelope requirements of the energy code for this warehouse. But the minute those mechanical systems do exceed these thresholds, that envelope in its entirety will have to meet the energy code requirements. Now, I want to point out the definition for newly conditioned space. This is a space that already exists. It was built in 1910, let's say. It's that warehouse. It's a brick warehouse with a ton of single pane metal windows. It's gorgeous, right? And now we want to turn it into office space and we want to make it habitable. So to be habitable, we have to add heating, and that heating has to meet 68 degrees Fahrenheit, 3 feet above the floor on the coldest day of the year. I assure you, you will exceed that 10 BTU per square foot of heating to meet the habitable space requirements of the building code. And that's what we call a newly conditioned space. It existed previously as an unconditioned space, but now we're converting it to conditioned space. And it is considered an addition by the energy code. And in addition, the envelope features, all of them, even though they were existing, will have to meet current code requirements to show compliance to the energy code. Now we have exterior partitions and we have demising partitions. Exterior partitions are separating that enclosed space from the great outdoors. Whereas a demising partition, which is probably not the definition you think it is, because the energy code likes to do their very own definitions, a demising partition is separating an enclosed conditioned space from an enclosed unconditioned space. So think about an enclosed parking garage that is underneath an office building. That floor is now a demising partition because above the floor is conditioned office and below the floor is unconditioned garage. Both of these partition types will have energy code requirements, but they'll differ because that demising partition is not subject to as much heat transfer as our exterior partition requirements. Hence, typically the requirements of the energy code are less stringent than they are for an exterior assembly. Now we need to talk about scope of work. Is it new construction? Is it an addition? or what we like to call newly conditioned, which is considered an addition? Or is it an alteration, which has code requirements of the energy code? Or is it a repair? Repairs do not have energy code requirements, but repairs cannot increase the pre-existing energy consumption of that particular component, nor can it have alteration requirements of the energy code for it to be considered a repair. And it's not easy to navigate the difference between repair and alteration, and strongly recommend, if you don't have an energy consultant that you like to reach out to see, hey, did I trigger the energy code? You might want to send that question in to Energy Code ACE or to the CEC hotline to get a really good feel if your scope of work triggers the energy code. Now, there are various organizations we need to be aware of when we're talking about the energy code, such as Cool Roof Rating Council. Oops, which is spelled wrong. Cool Roof Rating Council certifies a cool roof roofing product, and we have cool roof requirements, or what we like to call rated roofing material requirements, for all new construction, additions, and for many alterations for most non-residential projects. We don't always for single family, but we do for non-residential. The Department of Consumer Affairs certifies products as being insulation and radiant barriers. So sometimes I'll have a client going, Gina, we're going to be using dent shield on our walls, and then we have insulation between the framing. I have continuous rigid insulation because I'm using dent shield. Well, Dent Shield is not a rated insulation product by the Department of Consumer Affairs, hence cannot meet the requirements of continuous rigid insulation of the Energy Code because it's not certified as an insulation product. Now, I find finding the certified list of rated insulation products can be elusively difficult to find. So I strongly recommend all of you grab this hyperlink that I have here and save it because it's not easy to find. And in there, you'll see there's an Excel sheet download that supports the current certified products. So you're going to have to keep coming back to see if any new products have been added over time. National Fenestration Rating Council certifies the energy efficiency of window fenestration features, whether it's a window, a glass door, a skylight. And you'll see that there have been changes for this 2022 code cycle that's really pushing towards all window products being NFRC rated or certified. And there's very few exceptions to having to have an NFRC certification. I'm finding this is causing havoc out in the field where contractors are not up to speed on this. And we really need you, the architects, to be very clear in your specifications and your window schedules about what is the certification requirements associated with the window products of your projects. So I have a question for you guys, if you wouldn't mind answering in the chat, not the Q&A. I want to keep Q&A open for questions. Let's do this in the chat. Envelope requirements apply to, not thinking about those daylighting requirements. What do the envelope requirements in the Energy Code apply to? All enclosed spaces, conditioned enclosed spaces, unconditioned enclosed spaces, or non-enclosed spaces? I got a couple of people who are quick on the draw here. Excellent, everyone. That is going to be B, conditioned enclosed spaces, with the exception of the daylighting requirements, which will apply to unconditioned enclosed spaces, but that's really an atypical thing. The insulation, the window, the cool roof, everything else we're going to talk about only applies to conditioned enclosed spaces. Which scope of work is not subject to the Energy Code if you're lucky enough to make sure that that definition meets your scope of work? Excellent, guys. That is going to be repair. Just be really, really sure your project's not an alteration and truly is a repair. One last question. What compliance pathway can you pursue for your projects? Are we going to use the prescriptive approach only, which is documented with the NRCC E&V form, or could you consider the performance approach for just your envelope to get flexibility for what's required by the Energy Code? Excellent, guys. That's going to be both of the above. If you are just showing compliance for just the envelope, I'm not including mechanical, I'm not including electrical, I can use the prescriptive approach, which is going to be the NRCC EM4. It's pretty restrictive. There's no wiggle room here at all. If you need wiggle room for your envelope, you can use the performance approach for just the envelope. You can also add mechanical systems. You can also add electrical systems, PV, battery, etc., but you don't have to. What's great about non-residential hotel motel compliance currently is that you have that flexibility. Right now for multifamily, we don't currently have that flexibility, and I'm hoping that will change in our next couple versions of software. Okay, let's talk about opaque features. These are features I cannot see through. Let's start with the roof. But before we get there, some important definitions. U factor versus R value. Now, the thing that's important here is that the R value is only something that's going to be utilized per the materials that are approved by the Energy Commission as materials that can build up that R value, knowing that insulation has to be insulation that's certified by the Department of Consumer Affairs. Now, U factor is the inverse of R value, considering all of the assembly layers associated with each of our assemblies. Now, there are some restrictions there also per the Energy Code of what we can utilize that determines the U factor. When we talk non-residential, hotel, motel, and multifamily compliance, we are mostly going to be talking about U factor, because we are going to be looking at what is your framing configuration, what are your layers of insulation, and where are those layers of insulation? What are other features that might be associated with your assembly, like it's a double wall assembly, or it's a staggered stud assembly, things I'm going to take into consideration that isn't all about just the R value of the insulation products associated with the assembly. Now, when I talk about non-residential and hotel motel guest rooms, I'm going to go into the code sections of the code book of subsection 140.3 specifically. Then there's another section that speaks to just the alteration rules associated for envelope, associated with our non-residential and hotel motel rooms. What is brand spanking new for this code cycle is that they created 3 new subchapters just for multifamily occupancies. And we would go to subset chapter 170 for the new construction rules, and then we would go to the 180s for how the rules change for additions and alterations to multifamily buildings. Let's start with the roof. I like to start at the top of the building and work my way down. Now, one of the things I want to tell you guys is that there are some aggressive alteration changes of the Energy Code associated with re-roofing in this 2022 code cycle. And it is throwing roofing contractors for a loop. So you might have to do more to support what's required of the contractor when we're talking about a project scope that includes anything to do with altering the roof. Now, we need to understand some definitions when we talk about alterations to the roof. So here's this brand new fact sheet that we just came out with, and here it's providing to us some important definitions, so many definitions that we need to know about. And we need to know the definition of roof recoat versus roof recover versus roof replacement, because we're going to see that the requirements for the roof will change for a roof recoat versus what's going to be required for a roof recover and a roof replacement. I'm finding that almost everyone agrees with what the definition is for roof replacement, but there is a lot of stuff going on out there and people trying to determine scopes of work fitting into roof recoat versus roof recover. It's been so fun to be part of this process. So let's talk about our cool roof requirements for new construction. So we need to know the slope of the roof. A low sloped roof, that's a roof that has a pitch of 2 and 12 or less. You will see that all non-residential buildings of all climate zones are going to have cool roof requirements. If it is a hotel motel building, you'll see that only the guest room area of that hotel motel building in some climate zones have cool roof requirements. Who's going to do cool roof over only parts of the building? That's never going to happen. This is one of those things that they're talking about changing for the 2025 code cycle by not defining hotel motel by just where the guest rooms are, but that entire occupancy. Now, the minute I have a steep sloped roof that's a pitch greater than 2/12, you'll see that both non-residential and guest rooms have the same requirements, which is very much dependent upon climate zone. Climate zone does determine whether you have to consider cool roof or not for a steep sloped project. So I wanted to give you guys a feel of what does that 0.63H solar reflectance mean to me. So I went into the Cool Roof Rating Council database, and I love this database because I can sort by color. I can sort by product type. I can sort by age solar reflectance. And I'm trying to hide the innocent here because we at Energy Code ACE cannot promote one product over another. But I want to show you that there's lots of choices. And what I find is almost always you guys are already specifying a cool roof, even though you don't know it. And it's usually, if it's white, a pretty gosh darn good product. And in the performance approach, I can take advantage of what you wanted to use anyway, because it exceeds these values. So this is one of those, it seems like a small discussion, but it can make a big impact to your compliance margin in the performance approach. Now, there are some exceptions to cool roof, such as in certain climate zones. If you're giving me a certain U factor, well, then you've already saved the planet, and I'm not going to make you have to do cool roof. If you have a heavyweight roof, such as an occupied roof, we're not going to make you have to do cool roof because the two don't really coincide with each other. If the roof is an integrated PV panel, not a PV panel on top of the roof, but the roof itself, think Tesla roof systems, is the PV system. That PV system does not have to meet the cool roof requirements. And there is an ability to get trade-offs for the specific cool roof requirements by adding more insulation to the roof. Why might you want to go there? Sometimes we have glare requirements in certain cities that if you're surrounded by buildings that are higher than your roof, we want to prevent the glare into those spaces. And so we don't want a bright white roof. Maybe we have to do a tan roof. You also might have requirements around airports or observatories that might talk about the glare requirements. I always like to say when it comes to exceptions, read them first. Start with the exceptions, see if you even have to read further about what the energy code requirements are to determine what your scope of work is going to have to do to support the energy code requirements. Now, roof insulation is a thing, just like we have wall insulation and floor insulation. It does differ on building type. Here you'll see metal building. Metal building is a prefab metal building. It's metal panels. It's not the same as a metal framed building. If we have a metal framed building, a wood framed building, a SIPS building, I don't care, any other type of building, that's when we go to the wood framed and other. And I just thought I'd give you guys an example of the most common U factor we see here for most climate zones at the 0.034. One example is I have 4 inches of concrete up there on my span deck, plus I'm going to have 5 inches of R5 polystyrene. If I want to use polyisocyanurate, I'm going to have maybe only 3.5 inches. If I don't have the concrete, well, then I might have to do more insulation because I don't have the mass. I have a wood framed roof. Well, this is going to then represent R38 or R30. But if I have a metal framed roof, now you're going to start seeing we have layers of insulation. I still want that R38, but I'm also going to have to provide continuous insulation that equals R15 in this example, or R12 if I'm using 2x10s, 24 inches on center. I don't have as much framing interruption, so I can go down in insulation to help to then still meet that overarching U factor of 0.034. Now, when we're talking about re-roofing, if you're re-roofing more than 50% or more of the roof, or 2,000 square feet or more, whichever comes first, and it's a recover, a recoat, or a replacement, you're going to trigger the same exact requirements we just talked about for new construction. the same exact exceptions for alterations as we saw for new construction. What's different is regarding the roof insulation requirements. And this is, I'm just concentrating on low sloped roofs or flat roofs right now. If you recover or replace the roof 50% or more, 2,000 or more, whichever comes first, we have some new aggressive insulation requirements, which in most climate zones is going to be R23 continuous insulation. Now you do have a U factor, but they did say, hey, yeah, we'll let you think about the U factor and how much insulation might be below the roof deck. But we want at least R10 or more insulation to be added above the roof deck. This is all about trying to deal with condensation issues, concerns, et cetera, and so forth, in which having that insulation before we get into the warm area of the building, building science says, hey, insulate on the outside before going to the inside. And that's going to help prevent some of the moisture condensation concerns many people in the industry have when we talk about cool roof products. Got to tell you, roofers are struggling with this, because what happens when you have parapets that have curves that don't allow for an additional 2 inches of insulation? What happens for that threshold, for that entry from the exit of the stairs to the roof? What happens to the various pieces of mechanical equipment that are on there? What happens to your PV systems that are on stanchions up there on the roof? How can we do all of this? Now, there are some exceptions, but they're not as much as people would love to have, such as if you're recovering and you add new R10 insulation, you do get some exceptions. If you're not lifting the mechanical equipment, you do have an exception, but there's no exceptions for the parapets. There's no exceptions for the PV panels. There's a lot of things we don't have exceptions to. Roofers are struggling. So if you guys are dealing with remodel projects, really think about how you're going to support these requirements with your details to help support what's going out in the field. Becky's asking, I want to confirm wood frame roofs do not require continuous insulation. That one example I gave you, Becky, would not require continuous insulation. I gave you one example of how we can meet the U factor. That is not representative of all assembly types. So that was an example only. Example. I'm going to say that over and over again, because you're going to be like, Gina said, and we never want it to get back to Gina that someone said Gina said. It's happened. Walls. Okay, so new construction based on climate zone and wall type. Here's that metal building again, our metal framed wall versus our light mass walls, our heavy mass walls. We have definitions that help us understand whether it's heavy mass or light mass. Wood framed another, that's that category that everything else I didn't mention is going to go into. And let's take an example. I find most non-residential projects use metal framing, and we have a 0.055. Here's some examples. Now you'll see here with metal framing for my walls, it's really not possible at all to get this U factor without having an additional layer of continuous insulation on the wall. It could be on the outside of the wall. It could be on the inside face of the wall. It can be within the wall because it's a staggered stud wall. There's many, it could be a SIPS, well, it wouldn't be SIPS because then it wouldn't be metal framed, but there's many ways you guys can go about doing this. Now, let's talk a moment about Z-clips. Z-clips come in different flavors. You have metal Z-clips, you have fiberglass, you have isolated metal Z-clips. If it is a pure metal Z-clip and it is spaced 24 inches our center or closer, those Z-clips have to be modeled as metal framing interruption. And all of a sudden, all this work, expense, and everything we did to get this additional layer of continuous insulation is negated. So we really have to think about what are you using for Z-clips and what is the spacing and what does that do to your overall compliance for your wall assembly. Alterations for walls. So if you are making an existing wall accessible, you're taking the outside face off, you're taking the inside face off, I don't care, you're rebuilding a wall in the same exact location, that is an altered wall. And now you just have to meet the mandatory requirements of the energy code. Now I start talking R value. And if you have a metal framed wall, fill it with R13, walk away, call it done. If you have a wood framed wall, fill it with R11, walk away, call it done. Now, if it's a demising wall, that's when we have to start talking, because demising walls, if they're metal framed, remember that demising wall is separating enclosed unconditioned from enclosed condition. Wood metal framed has a U factor of 0.151. You cannot get 0.151 with a 4-inch metal wall, a 6-inch metal wall, with just R11, R13, R19, R21. You can't get the 0.151 unless you also have either continuous insulation or it's a fire rated wall in which you have 2 layers of 5/8 gyp on either side of the wall, both sides. So there's a lot of discussion that has to happen regarding what's happening to demising walls. And I forgot I had that fun little information on that slide. So I have a question for you guys. An alteration trigger for complying to the roofing requirements is going to include which scope of work? Which of these or all of the above is going to trigger cool roof requirements for all climate zones for non-residential buildings, for low sloped roofs? Excellent, everyone. That is that D, all of the above. Excellent. Now, what is the trigger for low sloped roofs when we talk about having to insulate that altered roof? What is the trigger for having to insulate that altered roof? With me saying D is not the right answer. A is right, and I want you guys to give me one more letter. A and what else is a trigger for the insulation requirements of this energy code? Excellent, everyone. That's going to be A and C. Recoat does not have to meet these requirements, which is why everyone right now wants to call their re-roof project a recoat. And they're almost always wrong. Let's talk about some of the new air barrier requirements of the energy code. And you'll see I still have fenestration to talk about, which is a beefy topic. And now you know why I'm talking so fast. I'm hoping you guys are getting this. I know you guys want the handout, and I'm hoping you'll take our non-residential architect class, in which we talk a lot slower and we do exercises to apply these code requirements. Gina can talk slower. Air barrier. Now, we had air barrier requirements in the 2019 code, but only for new construction and only for certain climate zones. And it was very limited in terms of what was required. They beefed it up in this code cycle, and it needs you, the architect. This is going to be required for all non-residential buildings in all climate zones, and for and for hotel motel buildings, except for climate zone 7. So non-residential multifamily, multifamily does not have any air barrier requirements. Non-residential in all climate zones, hotel motel, all climate zones except for climate zone 7. The design documents, there's new requirements for you guys. The design documents have to include the air barrier boundary, which is the conditioned envelope. So if I have a mix of unconditioned spaces, and there's kind of like I like to call innies and outies going on, you need to help define where is the air barrier. And now that we've defined the air barrier, we need to make sure that all your interconnections and penetrations support the air barrier. What is the air barrier? Where is it? How are we caulking and sealing for windows and penetrations and transitions and interconnected walls, et cetera, and so forth, to maintain a continuous air barrier? And then you're to provide the total square footage of all sides of the air barrier within the design documents. Now, they didn't give you any guidance on what this associated square footage looks like. So we're in a whole new world here. What does that look like? What are examples of that? Currently, right now, Energy Code ACE is working with AIA to help produce some standard details that help support some of these requirements that we're talking about. So I'm hoping you'll look forward to that on our Energy Code ACE website with what's being done in conjunction with AIA. Now we have, what is the air barrier? We have a table 140.3, that lists a whole bunch of materials that are automatically an air barrier product. And that could be chipboard, it's plywood, it's all different sorts of products that are considered an approved, pre-approved air barrier product. If we do not have those pre-approved features in the assemblies, then we have to test the building once it's been built with a blower door test to make sure all of the assemblies do not exceed an air leakage of 0.04 CFM per square foot. I don't know about you guys, but I get a little bit nervous when I'm depending on all these contractors to maintain the air barrier, which is why at the design stage, it's so very important for you guys to make sure that air barrier boundary, but especially your details with the interconnections and penetrations, clearly indicates how to maintain the air barrier. So Mark is asking, how can architects best show the air barrier on drawings? I strongly recommend taking our non-res architect class, in which we give you all sorts of different ways that you can play with and consider that might work best for you. Chipboard and plywood of certain thicknesses, not all chipboard, not all plywood. I think it's 1/2-inch plywood. I'd have to go to the table to get exactly what the thicknesses are. But yes, chipboard and plywood are on that approved list as an air barrier product, dependent upon depth of the product. You can volunteer to have that blower door testing because you want to. I have yet to have anyone want to do that, but it's a choice. Now, alterations to our non-residential buildings and our hotel motel buildings, except for climate zone 7, we have new air barrier requirements. If 25% or more of the exterior walls are being made accessible, or you're rebuilding in the same exact spot, then we're going to do our blower door testing. We're going to do some things. We are going to make sure you're using that air barrier product. There's things we have to consider for alterations to existing buildings to maintain the air barrier, the trigger being 25% or more of the exterior wall square footage is being made accessible or being rebuilt. Fenestration and solid doors. Okay. I have 13 minutes. So we'll see that non-residential and hotel motel buildings are still in section 140.3 and for alterations section 141. But for multifamily, remember, we have whole new chapters. We're going to go to 170 for fenestration also, along with our opaque assemblies, and the 180 sections for additions and alterations. We have 3 different definitions of fenestration products. We have manufactured products, we have site-built products, and we have field fabricated products. Manufactured products are products that are available to everyone from a manufacturer. You can go to Home Depot and buy them, right? They weren't made special for your design at that site location. When it is a manufactured product, it is to be NFRC rated, or you can use default values. Now, I got to tell you, default values cannot be used in the prescriptive approach. Default values represent the worst window known to mankind. And it's really difficult to show compliance in the performance calculation if you have a lot of default window. We can almost always get it to work when we have maybe a fire rated assembly, some certain doors that have glazing within the door, certain features. But the minute we start having over a certain amount of default windows, compliance is very, very difficult to achieve. So it means you guys really need to be up to speed on what products are NFRC rated when you're doing manufactured products, which is typically our punched windows. Site-built products is more common for custom skylights and for storefront or curtain wall are typically site-built, in which you're designing what that's going to look like, that's going to be manufactured at a manufacturing plant just for your location. Now you see we have more choices. We can do NFRC certified or rated. We can use the NFRC component modeling approach, in which there's some flexibility of how we use an NFRC certified lab to support the efficiency measures of that window product. We can use default values. but it's just as bad as it is for manufactured products. Very difficult to do. And you can use what we call the center of glass Na6 formula. This used to be very popular. 4 code cycles ago, you could use the Na6 formula for up to 10,000 square feet of site-built window products. It was the most popular method. Then the next code cycle, they dropped it down to 2,000. And then the next code cycle, they dropped it down, I think, to 500. This code cycle, they got rid of it, except for skylights. You can have up to 200 square feet of site-built skylights for your projects, and that's it. Multifamily, 3 stories or less. So this is low-rise multifamily. There's a little bit more flexibility, but barely 250 square feet or 5% of the conditioned floor area. The Energy Commission wants to get rid of this option, and they want to go to where it's either going to be an NFRC certified or component modeling approach by an NFRC lab, or the default, of which someone's asking me to clarify what is a default manufactured window. That would be, excellent question, by the way. That would be a manufacturer that feels, I have to be politically correct. That is a manufacturer who is unaware of or is unwilling to get their products NFRC certified or rated via the 2 methods available by the Energy Code. And there are some manufacturers out there that have access to the software that NFRC labs use to help set things up, but it's not being done by an NFRC lab. So sometimes we have these virtually simulated label, and they'll say, not done by an NFRC lab, but the manufacturer goes, but it's just as good as, you're fine, you're fine. No, you're not. And we need to make sure those manufacturers stop that stuff. And how it's going to it needs to start with you, the architect, to make sure we're doing products and we're specifying products that can do this NFRC testing. I have found so many contractors struggling and unable to get their final occupancy permit because they were not able to get the product that's already installed to be NFRC certified because the window representative misrepresented what the Energy Code requires, and it's becoming a major deal out in the field. So I'm hoping you guys will take our non-res architect class and learn more of the intricacies between NFRC certified, NFRC component modeling approach, and when can you use the Na6 formula, and how difficult is it to use default values when you have a manufacturer who has refused or is not aware of the NFRC testing protocols of California. Field fabricated products are products that are slapped together out in the field. I told Rebecca I was going to try and not be angry today, but Rebecca, I think I failed a little. I'm sorry. Okay, so field fabricated products are when I'm slapping things together out in the field. I get all the products from my Home Depot, and it might be a storefront wood stop window. It might be a stained glass window. It might be a glass block window. I can only use default values for field fabricated products, which is very, very difficult, as I've said, to show compliance in the performance approach. And there's no way to use default values except for a little teeny bit in the prescriptive approach. What are these efficiency values that are such a big deal about the testing, Gina? Well, we have U factor, we have solar heat gain coefficient, and we have visible transmittance. U factor is all about preventing heat transfer, and the lower the U factor, the better the product is performing. Solar heat gain coefficient is about how that glass product is preventing heat gain when the sun is hitting that window. This can be done with a tint, which we don't love actually in the Energy Code world. It could be done with a coating, and typically we've really gone to low emissivity coating, and it used to be low E, then low E squared, then low E triple. And now we're up to low E quadruple. And we keep adding layers of low emissivity film or coating to be able to meet some of these solar heat gain coefficient requirements of the Energy Code. Because we also have visible transmittance, how much natural light is making its way through that glass product to help light the space so that we don't have to turn on electric lights. You know, we want to save electricity, right? That's part of our major purpose of the energy code. The higher the visible transmittance, the better the product. So U factor, the lower the better. Solar heat gain coefficient, the lower the better. Visible transmittance, the higher the better. And I find most times I can meet the U factor and solar heat gain coefficient, but because of the many layers of the low emissivity film, or because I might be doing it in a less expensive fashion with tint, I am not able to show compliance to the visible transmittance. And that's almost, it's a double whammy. It's a double whammy because now you're increasing lighting energy, and by increasing lighting energy, you're increasing cooling energy. And it can be very difficult to get flexibility to the visible transmittance requirements of this energy code. So here's the table about what's required for our non-residential buildings. Here we have our vertical fenestration. Here's our U factor, SHGC. You'll see there's an R there because we get to take into consideration any shading that's associated with the building and or shading devices that are attached to the building that help support these requirements. And we have our visible transmittance. It does define a change based on window product. Is it a fixed window? Is it a curtain wall or storefront window? Is it an operable window? Is it a glazed door? What's brand new to this code cycle is fixed windows, curtain wall, and storefront windows now change based on climate zone. The last two code cycles, it was the same for all climate zones. They changed that for the 2022 energy code. It's also really important to understand your window to wall ratio prescriptive maximum of 40% for non-residential buildings. And you'll see that we have similar requirements for skylights. Here we have a 5% skylight to roof ratio. So this 0.41 U factor, a thermally broken dual pane product, using a Vitro Solar Band 90 Clear is an example of how I can get the 0.26 solar heat gain coefficient and be able to achieve the 46% visible transmittance or greater. Let's talk about architectural windows before we dive into multifamily. Architectural windows is a rating that is put out by North America Fenestration Standard Specifications that has been adopted in California for multifamily construction only at this time. Now, this is where I have structural loads on the building in which I need to have a window that has the structural integrity to be able to sustain the structural load. Most times it's wind load. So I do a lot of work here in San Francisco, and there are areas of San Francisco that the wind loads coming off the water is crazy. And the higher the building, the more likely the structural engineer is going to say, hey, you guys need an AW rating for your windows because of the structural loads that this building is going to be subject to. Now, when I have AW rated windows, I have more structural steel integrated into those windows, which is going to affect the U factor. So here's my table of what I get for fenestration for multifamily in this new code cycle. Guys, got it? We can move on. This is easy to read, right? So here we have our curtain wall, and here we have U factor. We have our solar heat gain coefficient if it's a 3-story or less multifamily building, our solar heat gain coefficient if it's 4 stories or more, our visible transmittance. And we have this new category of when you need an AW rated window, you will see that the U factor is a little bit more lenient than it is if it's a curtain wall or all other fenestration. This all other at 0.3 and 0.34, this is our punched windows. I was, whoa, blown away when I saw these U factor requirements, because we went from a 0.42, I think it was 0.41 to a 0.3 in this code cycle for multifamily buildings. Things got a lot more stringent if it's not an AW rated window, if it's not a curtain wall in this code cycle. Fenestration area is also very unique to multifamily in this code cycle. For non-residential buildings, hotel motel buildings, we saw that the window to wall ratio was 40%. For multifamily buildings, we're also going to have to show compliance to the maximum window to floor ratio of 20%. So I get 20% of my conditioned floor area as fenestration area, whether that be window or skylight or doors. And I have to show compliance to the 40% window to wall ratio for my vertical fenestration. Alterations, the rules will change based on how much is being altered and or how much is being added. There is flexibility that's being provided if you're altering under a certain amount or adding under a certain amount that, hey, we get it. Most of the building is probably a product that was allowed under the energy code a few code cycles ago, and it's going to look different than what's required of this code cycle. So they give you some leniency. But the minute you start altering or adding over a certain amount of glass, you're going to have to meet the same exact requirements as new construction. Robert is asking, is the window to wall ratio overall total building or per wall? Excellent question, Robert. So the window to wall ratio is 40% your north, south, and east elevations combined, and then 40% of your west elevation all by itself. Fun, right? So elevation matters, west all by itself, all the rest combined to get that 40% window to wall ratio or less. We have opaque door requirements. A lot of people are surprised by this. These aren't new. These pretty much, especially for dwelling unit entry, or common use doors, which does apply for non-residential also, pretty much represents an insulated door. Now, this can be difficult. So I find that not everyone is aware of that. I'm going to bypass these questions for you guys, and we're going to start wrapping things up for next steps because we're a little bit over time. We have classes for you. I talked about the architect class that I'm hoping you guys might take. We also have some stuff on our YouTube video that helps people regarding alterations. We have even more fact sheets about what's new. Reference Ace is a great tool. Here's where you can go to ask more questions. If you want to reach out to me, my email is decoding.request@energycodeace.com. If you'd like to reach out to Jill Marver or Dave Intner or even Jeremy Reef from San Diego Gas and Electric, they would love to hear from you. And I'm hoping you'll take my course evaluation. Let's now have a little Zen moment. As we then proceed to see if you guys have any questions. So Barbie is asking, what is the architect class I mentioned? We have a non-residential architect class, and we have a single family architect class. They're available now on our website, and that's what they're called. It's a single family architect for the 2022 code, non-residential architect for the 2022 code.